Hey guys, so in this video we're going to be talking about Dimetrodon. Hey guys, so in this video I wanted to talk a little bit about Dimetrodon and some of the research that we're actually studying right here in Seymour, Texas. Dimetrodon was discovered in 1877 by Edward Drinker Cope and was the largest land predator of the lower Permian, about 290 million years old. This is the point of the Permian that we are actually researching. Before I get into the characteristics of Dimetrodon and all that kind of stuff, I kind of wanted to explain what makes him not a dinosaur, because I get this question a lot when I'm giving tours. So I kind of wanted to explain the differences between Dimetrodon and kind of the overall characteristics of a lot of the Permian animals and what makes that different than dinosaurs. So firstly, okay, if he's not a dinosaur, what do we call him? So he's actually called a non-mammalian synapsid. So it's a really big word, and so basically Dimetrodon has characteristics that resemble a mammal and a reptile. So he's not actually direct descendants of mammals or reptiles, but he has characteristics that mimic mammals and reptiles, and he will eventually over time evolve into mammals, if that makes sense. So essentially, if it wasn't for Dimetrodon, we wouldn't be here today. Dinosaurs wouldn't have existed. So really, we really owe it all to Dimetrodon. So the term synapsid actually refers to the opening behind your eye. So essentially, I'm going to put a photo of a Dimetrodon skull on the screen. He has one opening, so he has like one hole behind his eye, and that's used for muscle attachments. And humans actually have a resemblance of that fenestral opening. If you put your, I like to do this with kids and tours, if you put your fingers like right here in front of your ear and open your mouth, you can feel that hole there. It's not really a hole, it's more like an indentation now. Remnants of a fenestral opening that Dimetrodon had. And what makes that different for dinosaurs, they are called diapsids. So they actually had two holes, they had two fenestral openings behind the eye socket. So essentially, when you're calling something a synapsid, it just refers to the amount of holes that are in the skull. So, but if you look at, like, let's say a T-Rex skull, I'll put that on the screen, he has two holes behind his eye instead of one like a Dimetrodon, but he also has a hole in the center of his skull, which Dimetrodon didn't have, and that could be because of how large his head is, because they were really big animals, and he had a really large head, so his head would have been extremely heavy, so our theory is that he had that extra hole in his skull to essentially make his head lighter so he wouldn't just like fall over and wouldn't be like too top heavy. And he also mostly had a extra hole behind the eye just for extra muscle attachments because their jaws were really strong, so it just made his bite a lot stronger. So now that we described what a synapsid means, what a diapsid means, now I'm going to talk about other things that make him not a dinosaur. So when you look at, I'm going to put a photo of a Coelophysis, which is a big raptor type dinosaur on the screen. And if you look at his body structure, his legs go straight down. And that is just like birds today. So that's another thing that makes Dimetrodon not a dinosaur, is that Dimetrodon wasn't related to birds, but most dinosaurs were related to birds. So dinosaurs and T-Rex and even like Triceratops, all their legs go straight down from their body. But if you look at Dimetrodon, his legs kind of go out like a 90-degree angle. And that is a very mammal and reptile characteristics, was his legs sticking straight out from the body like this, and his ankles. So that was a big mammal, a big distinctive mammal and reptile characteristic that dinosaurs just didn't have. So another thing I want to talk about is his giant cell. So there's a lot of like theories on what they could use his cell for, what he used it for, and a big one that I want to debunk is thermal regulation. It strictly just wasn't possible. If you look at a cross-section of a Dimetrodon cell bone, it's very, very dense. It's not porous. There's not enough room inside his bones for there to be a lot of blood vessels, if that makes sense. And if you go back and look at the ecosystem of the Permian during that time, it was very, very hot, very humid, and there was no reason for him to have to like regulate his temperature, because his temperature was already regulated because it was already hot all the time. There would be no reason to have thermal regulation. So if it's not used to keep him warm or cold, then why does he have a big cell on his back? So normally when animals have weird things sticking off their body, it's most of the time just used for display. So other animals and other species can easily identify what you are. So essentially the animals don't breed with the wrong species. But not everything has to be overcomplicated. A lot of the times the answer to things are just really simple. But for the most part, it's usually just a simple answer that is just used for display and used to attract a mate. I'm going to put a photo of Dimetrodon on the screen, and you can see that a lot of paleo artists and toy companies make their cell bones actually stick out of his cell, like stick up off the top, and there's no way that's functional, because there is no animal today where their bones are just sticking out of their body and not being covered and protected by skin and muscle. Sorry, my camera stopped recording. What I was saying is a lot of illustrations that we see of Dimetrodon today, they make him appear to have a really thin cell, and you can see the outlines of each one of the cell bones, and that's probably not super accurate. I mean, he would have to have a lot of muscle, a lot of tissue covering the bones to keep it from flexing and keep it from breaking. So this is gonna sound a little weird, but hear me out. So if you look at bison, they have this large mound on their back, just a huge muscle mound hump on their back. And if you actually look at their skeletal structure, I'll put a photo of a skeleton of a buffalo on the screen. He actually has cell bones, I mean, sticking off his vertebrae, huge neural arches. And you could argue that buffalo have a cell, and it's possible Dimetrodon's cell could look something like that. So we probably have no idea what Dimetrodon looked like. I mean, he could look totally different than what a lot of people are portraying him to look like today. So it's possible in the near future we could be describing Dimetrodon totally different than what we have describing him since 1877. So I think I'm going to stop this video here before I go on a super long rampage about the way that people are describing Permian animals wrong. So if you want me to actually do separate videos on talking about each individual specimens that we have multiple different Dimetrodon skeletons, and we have different species of Dimetrodon that we find out here in Seymour, Texas. So if you want me to kind of do a video explaining the differences between different Dimetrodon species and the differences between our current skeletons that we have, let me know in the comments below, and let me know if you enjoyed this video, and I'll see you in the next video. Bye guys!